Welcome to Chapter 13, Renewable Energy and Conservation. We're looking at here is an area, developing country. Back behind you can see the hut. That is where they do their cooking. And this is a solar panel. So they're actually getting energy to help them survive from the sun. Photovoltaics, while they are expensive, help. You can look around here and they've really utilized all their natural resources. It's an area where nothing's growing just right in this vicinity, and it will help maintain habitat by using something like this. However, since they are poverty stricken, it's up to people like us to donate and help with services that provide a type of energy just so they can eat. If you look at direct solar energy, there's two types we're going to be discussing. One is passive, one is active. Passive is just using that sunshine beating down on the earth and converting that then to a heat. Then active is taking that heat and actually doing something with it, such as using the photovoltaics that you saw in the first slide. So here, if we look at the United States, this is just showing the amounts of solar energy that we get. Realize that Germany uses solar technology more than we do. In fact, and they get less sunlight than we do, more like what you're seeing in the Northeast to upper Midwest. Okay, let's look at passive first and how we can use that. Now, down here, we're not going to want to use passive to heat our homes because our homes, we're trying to cool them. But south-facing windows that allow the sun to come in and heat up the room, utilizing insulation, which we can do down here to help keep it cool. Up north, they can insulate their buildings so that it holds the heat. Attic vents, particularly for us, will let the heat escape in our attics, because when you're trying to cool down your house here, if you don't have an attic vent or a flow, all that hot air rises, and so you get 120 to 150 degree heat up in your attics. So then we also have overhangs, which allow for the sun to stay out in the summer, but as the sun is lower in the winter, it can access the windows, so it works two ways. And then we'll discuss the solar sun space in just a minute. Okay. Looking at this is a graphic of what we just talked about. And look at the summer sun versus the winter sun. Summer sun being blocked, and winter sun then being able to get in and to warm the spaces. This is a sun space actually utilized in California. I had a student from California, and she said they had one of these on their house. So I had never seen one until she showed me pictures of hers. You have the glass, which creates a greenhouse effect, where it traps the heat. Just think about getting in your car in the middle of the summer. It's a lot hotter than outside. Sometimes you have to leave the doors open just a little bit so you can stand to be in there. But the glass traps the heat from the sun, and then those are barrels just painted black, and those black barrels then have water in them. So the water, high specific heat, holds the heat. So basically then that's on the outside wall of the home, and then look at the air spaces that they have. They can shut those off from the inside of the house, but they have a flow of nice warm air coming in and cooler air going out, so it actually circulates. And because in the areas where they were using this, it doesn't get frigid cold, they can utilize this in the evening time and just take the chill out of the house. So it's very effective in places that have moderate temperatures. Active solar, what you see here, you've still got the sun heating up a unit, and this is a solar collector. It has a liquid in it that can maintain heat. It's not just water, because the water would vaporize and boil. So this is a liquid, and it goes into this heat exchanger. So it heats this area up, which in turn heats the water up, and then it's stored in the hot water tank. Then you can have a nice warm shower. One of the things you don't think about hot water a lot, especially here in the United States. You turn on your tap and it gets hot. But that can be up to 30% of your electric bill, not including your air conditioning in August, obviously. So it really does pay if you can utilize some other technology to heat your water in your hot water tank. Because you're heating it not only when you're using it, but you're also heating it throughout the day. Even when you're not using it, you have to keep it hot. So you have electricity flowing to keep that going. This is usually the solar thermal utilized in large area or large grids, and basically what we're doing is collecting the sunlight and intensifying it into these pipes. And again, you're using the liquid that can tolerate high heat. In fact, if you touch this, it'd probably burn your finger off just immediately. And then it flows through these pipes, and then basically what we're doing is we're going to end up creating heat that turns a turbine and creates electricity, just like what we talked about with nuke energy and with coal energy. So this is a huge grid in Arizona. These are photovoltaics. This is what you see in the panels that go on people's rooftops. Basically, you see the panel, and inside the panel you see these little wafers. And the wafers actually have a flow of electrons, and that flow of electrons then actually makes everything work in your house. There's a couple of reasons why more people don't have solar. The initial investment is in between $15,000 and $20,000. You do not get that investment back unless you have utilized this for 15 to 20 years. And then you get your investment back. A lot of people are not sure they're going to be in their homes that long, so they don't want to invest in this type of technology. Also, down here in Florida, where we have high wind threats and hurricane threats, people are afraid that that's going to blow off their house, and then they'll have to reinvest and not have electricity for an extended period of time. Now, most people who do have solar also are hooked up to the main FP&L electric grid. What happens is, with this FP&L and most other places in the United States, if you create more energy than you use, it actually turns your meter backwards. So you actually save, because they can utilize your extra energy, and it can go into the grid. So that's kind of a nice thing that can take place. But more and more we're looking at maybe some alternatives that would be better suited to Florida. But still, the expense at this point, especially when now we're looking at oil and gas being so cheap to utilize, and natural gas not really putting a lot of toxins into the environment. So this is just an application that is becoming available where it's actually, the solar panel is actually embedded into the roofing material, which makes it a lot more hardy and something that we could use down here. Also, they're looking at applications for installing them in windows as well. This just gives you an idea of how much it costs for some different alternative energies. And the least expensive is going to be one of the indirects, and that's hydropower, which is in part 2 of this. And you can see that the photovoltaics, which are the solar panels, 15 to 22 cents, and really not coming off of that. Natural gas, 5 to 7 cents, which is still relatively current, even though we've dropped in gas price. And this is where we'll start part 2. That is the end of part 1.